Hi everybody, I'm Julia from a barrier and you see me here together with my colleague Gero to show you our new TIMEBOW imaging. We sit in front of our facility line and Gero will now demonstrate us how TIMEBOW imaging works.
Thank you, Julia. Let's have a look how this new feature works. Here we have a plant cross-section. And what we see here is not dyes, but simply the autofluorescence of this sample. And that by itself can be very interesting. Let's zoom in a little bit. And here we see an intensity image of that autofluorescence with a little bit more detail. But the interesting part is when I activate TIMEBOW, and then we get a lifetime image. And lifetime is here represented in different colors. Additionally, we get a phasor plot here on the right. And what we can see there is short lifetimes going along this bow or arc shape to longer lifetimes.
This is why we call it TIMEBOW. And each time point on the TIMEBOW represents a different color in the image, or?
That's correct. So starting from short lifetimes, that would be blue here. Going to longer lifetimes, say 2 nanoseconds, that would end up red on the left.
Yes, and this provides, of course, much more information about the image.
Yes, and this is how we give time a color.
Gero, can I separate individual lifetimes into separate channels?
Of course, and we have a simple tool for that. Basically, you just draw a region of interest, a circular one here. And I can move this now along my phasor plot, selecting here longer lifetime species, and here extracting shorter lifetime species into my image channel. Starting here with the longer ones, I can draw another region of interest, place it somewhere around here, and I get another channel. I can give each channel individual colors. And I can add yet another region of interest, say up here. Move this a little bit around. And give this another color.
And when I want to use more than one dye in my sample, can I separate it as well?
Yes, of course. And there it's important that you have dyes with different fluorescent lifetimes. And then you can separate them using the same tools, even if they have the same spectral range, which means you get basically some bonus imaging channels in your microscope.
When you're talking about the microscope, I also have a question regarding the detectors. What kind of detector do you need for the TIMEBOW images?
You can use the standard detectors in our microscope, or you can switch to the matrix detector, which has some added benefits. And the matrix detector is basically an array of detectors and can be used to suppress the background and autofocus light significantly to get crisper images. An example would be an image here, a standard intensity image. And when we activate the matrix menu here, we can significantly reduce the background signal here and get a lot more contrast, I believe. You can see that there's a lot more contrast between the lines, for example, and also in sharper regions here you can see gaps appearing. What I would like to show as well is that we can combine this with lifetime imaging here. And if I make this brighter, you can see that we have now here really separate lines. However, the lifetime information is still preserved here and can be displayed. And I think this is a unique combination which you don't really find in any other microscopes.
And what about STAT? Can I combine STAT with TIMEBOW imaging?
Yes, of course. And we can actually use TIMEBOW to increase our resolution, especially when we're working with low STAT laser powers. And for that, we will have to have a look at a different sample. Next, we are looking at a layer of Caco cells. And these nicely show the benefits of matrix detection, TIMEBOW, and STAT. And we can combine all three to get the best image possible. On the screen, we can see on the left a confocal image of the Caco cells, and in the center, a STAT image. the stat image doesn't yet look so much sharper than the confocal image, and that's partly due to the fact that we're using a very low stat laser power, 2% to be exact. What can we do to improve this? We can use the matrix detection to reject lots of the confocal or low resolution components. And we can see immediately that we have a much darker background and the fine structures are accentuated here. We can take this another step forward, and I'll show you how. Now I'm using the TIMEBOW feature here to select the higher resolution components in the image and display them here on the left. I'm doing this via a line selection tool, and one end is here at the long lifetime components and one end at the short lifetime components. I can change this line and reject more of the short lifetime components, and you can see in the image that you're now getting a higher resolution and more contrast. I think we can see the difference even better if we zoom in a little bit and then reject the short lifetime components to increase the resolution. I think we can see the resolution going up. If I include these short lifetime components, we see more hazy background, and here again we see a sharper image.
Yes, nice. So the difference is clearly visible, and TIMEBOW helps us to improve the resolution of our stat image by using the time information.
Yes, and what I find surprising is that we're just using 2% stat laser power here, but with the TIMEBOW feature we can still get a high resolution out of the raw data here.
So TIMEBOW is freely combinable with confocal imaging, stat imaging, and our matrix detector to get the most out of your sample.